I'm starting to record. I'm sorry, I'm starting a little bit late. So I'm going to start with interval notation now. Okay. Um, and obviously, any lateness is caused by computer glitches, and there are a lot of them, I know, is totally excused. Just let me know. You can send me an email after class. I don't look at my emails during class, or just come on whenever you can. Don't, but remember, I do record every lesson. And if you looked on your Blackboard, the recording is there. If you miss something and you want to make it up, you can look at the recording and you'll see exactly what happened in class. Okay? So we're talking about how to express an inequality such as x greater than or equal to -2 in different ways. And we're going to see there are actually 3 different ways. One way, of course, is just to write the inequality. Now, when you're writing an answer to an inequality, it's not enough just to write the number. You can't just write -2 because an inequality is not just the number, but which way is it going from that number? Is it greater than that number? Is it less than that number? Does it include that number? So you have to write the whole expression. X greater than or equal to -2. Not only that, you always really want to start these inequalities with the X. It's not wrong to start with a number first, but the rules that I'm giving you in terms of the arrow pointing in the right direction only work if you're starting with the X on the left side. And of course, it makes more sense. There's nothing wrong with saying -2 is less than or equal to X, which is really the equivalent of this. But it doesn't give you a clear picture of what's happening. -2, to say X is greater than or equal to -2 is the same thing as saying that the -2 is less than or equal to the X. It's saying the same thing. Remember, when you turn it around and you switch them, you have to switch the direction of the inequality as well. But this is not as clear. It doesn't show as clearly on the number line. And we're going to see also it doesn't show as clearly in this new thing that we're calling interval notation. So I will always write my inequalities starting with the variable on the left side. Okay, so that's one way of writing our inequality. Our second way of writing our inequality is by the number line, which is what we just indicated over here. I'm going to erase this because I really need the board. So for example, if we're doing X greater than or equal to -2, then on our number line, we put a full circle at -2 and an arrow going to the right. Remember, we talked about how, and this is specifically when the X is on the left side, the inequality sign even looks like an arrow or an arrowhead, and it's pointing in the right direction. See how this mimics this. So that's our second way, by doing a number line. The third way is what we call interval notation. The problem with putting things on the number line is, first of all, if you're trying to type it, it's hard to type this type of thing because you have to have a graph where you can put it on. So there is another way that really mimics the number line, and that's called interval notation. In the interval notation, all you do is put the two numbers that the number separated with a comma. I'll show you in a second, where the number on the left is the start of the interval and the number on the right is the end of the interval. In other words, you don't have to draw the picture, you just put in the numbers. Now, obviously, my interval, and you always are starting on the left and going to the right. So in this case, my interval is starting at -2. That's the first number. Put a comma. And my interval is, well, it's never ending. It's going all the way until infinity. So my second number that I put in, the number that's all the way to the right, I put in infinity. Now, it's not enough just to write the two numbers. You have to enclose these two numbers with either brackets or parentheses. And
Do you know when to do brackets or parentheses?
I'm sorry?
How do you know whether to
Yeah,
choose?
that's exactly what I'm going to tell you right now. When you're dealing with a filled in circle, you use a bracket. When you're dealing with an open circle, in other words, just a plain greater, that's when you use a regular parentheses. Now you can have, so at -2, since this -2 is included, that's why we're going to use the bracket. And we can use different symbols at the beginning of the interval and at the end of the interval. It turns out when the end of the interval, or when an interval includes the infinity sign, since infinity is not a specific point, I can't say it includes infinity. At infinity, we always put a parentheses. That's just the symbolism. You have an infinity, you only use a parentheses. So notice this is easy to type on your computer. So if you want to give an answer, it's easy to give it in interval notation. You don't have to draw any pictures, but it's indicating the exact same thing you're seeing on the number line. The first number is a number where you're starting. The second number is a number where you're ending. Again, if it's a filled in circle, you put a bracket. If it's an open circle, you put a parentheses. Now let me do a couple more of these so you see some examples, and then we'll do some actual problems, and then maybe we'll break up into groups. Does anybody have a question before I go on?
I'm just
Professor,
yeah. Go.
Okay, I hear two people talking. So who's asking? Just tell whenever you. I don't always see who's talking. So do me a favor. Just say your name before you start talking.
Professor, it's me, Jennifer. I got on.
Oh, great. Good. Okay. Any other questions?
Hi, it's
Oh, I'm sorry.
oh,
You can
I
go.
don't hear who are you?
please go.
Lisa.
Okay.
I'm having a very hard time hearing you. Can you get
Okay,
closer
well,
to your? Can you talk more into your mic or something?
Okay, well, it's me, Jonathan, and I just have a question. I'm just a little
Yeah.
bit confused about the when to use parentheses and when to use the other symbol. That's all.
Okay. We're going to do a bunch more,
Okay.
at least 3 or 4 more.
Mhm.
And if you still have a problem after that, ask it again.
Okay. Thank you.
You're welcome. Okay. So let's take an example like this. Suppose I have x is greater than 5. Okay, I'm giving you the inequality. Let's look at the number line and then let's look at the interval notation. Okay, to say x is greater than 5 means that I have to go to the number 5, which is right here, and decide at that point, do I make a...
It's going to be an open circle
It's going to be an open circle because this is just a...
because there's no, there's no line underneath it. So
I try to think of it. If there's something extra over here, then we need something extra over here. Just take that line over here and use it to fill in the, let's take the ink from that equal sign and we fill it in the circle. That's how I look at it. It's what's called a mnemonic device, an easy way to remember. If there's more in the symbol, there's got to be more on the number line. So this is just going to be an open circle. That indicates, the open circle indicates that the 5 is not included. But anything beyond 5, remember we're making our, here's our arrow. This is an open circle at 5. Let me just continue this line so you can see here 6, 7. So it's an open circle at the 5 with an arrow going to the right, because this looks like it's pointing to the right. If we want to do this in interval notation, so let's think, where does our interval start?
It starts at the 5.
Right. The first number
Positive.
we see is at the 5. Where does the
And it
interval
ends
end?
positive infinity.
Right, it's going on and on and on, so it's ending at infinity. Okay, so
And
everybody
then
okay with that part? All we have to do now is put in those parentheses. Now, at the infinity sign, I know that's always a parentheses. It's always a curvy one. There's no question about it. But what do I do at the 5? So here's where the difference between putting a square parentheses, a bracket, I'm going to call it bracket, and putting a parentheses, which I mean the curved one, is since the 5 is not included, we use a parentheses. The parentheses indicates that it's an open circle.
yeah,
So does that make it more interesting? Can you now understand when you use the parentheses and when you use the bracket?
Yeah. Mhm.
Everybody okay with that? Okay, because now I want to go to another problem. Let's look at another problem. Suppose I had given you x is less than 1. On my number line, so here's my inequality. On my number line, it's going to look like this. Here's 1, 2, 3, -1, -2. It's at 1, because this is telling me 1. Open circle or closed circle? Filled in or not?
Open.
Open.
Open
Not
circle.
filled in because it's just a less than. It doesn't have that equal sign, so it's going to be an open circle. Which way does my arrow point?
Left.
to the left.
Left.
Obviously, this looks like it's pointing to the left, and that's the correct.
Left.
How far is this going? All the way to negative infinity. Correct?
Right.
Okay.
So that's the whole thing's in parentheses.
This is the number line. Now let's talk about the interval notation. And this is where most people make their mistakes. So that's why I really always, even if I'm not required to do the number line, I always like to draw the number line. On my paper, it's easy to draw it if I have a paper and pencil. It might not be so easy to type it in. You might be able to, but it's easier just to draw. But if you have a paper and pencil or a pen, you can do it easily. And now we want to put it in interval notation. Now remember, in interval notation, I know I'm going to have two numbers separated by a comma, where the first number is the starting point, and the second number is the ending point. And remember, we always, on a number line, start all as far to the left as we have to. We start on the left, we end up on the right. Even though it looks like we're starting at 1 here, that's really not the starting point. That's the ending point, because that's the point that's furthest to the right. The 1 is on the second position. So what number is in the first position?
I mean, one number.
Negative
What?
Negative
The
infinity.
negative infinity, correct. This, don't make a mistake and write 1 and then comma negative infinity, because we don't go, when we're talking about an interval, we always have to go from left to right, and the leftmost point is negative infinity. Now we can put in the parentheses or brackets. This is an infinity sign, so it certainly gets a parentheses. The 1, is the 1 included or not?
So if you land at negative infinity, that means you're when you're doing the in the parentheses, that means you have to start with the negative infinity always.
Right. So here's,
So whichever is the most farthest left on the number line is the first number.
okay, the whole number line, let's talk about this. If I went from one end of the number line to the other end of the number line, I would be going from negative infinity all the way to positive infinity. That's the complete number line. That makes sense?
Yes.
But here, we're not doing the whole number line. We're only doing a part. We're doing the part, again, we're starting on the left. So the left point is negative infinity because it's as far left as you can go. And you're stopping at 1. On this one, our furthest left point was 5. So that went in the first position. And then it went on and on and on until the end, so that my number on the right was the infinity. It turns out that you can, if you have an infinity, a positive infinity, the only position it can be in is in the second position. Whereas negative infinity, the only position it can be in is in the first position, because you can never end an interval at negative infinity. You can never start an interval at positive infinity. You can go to infinity, or you can start from negative infinity, but you always have to consider you're going from the left to the right.
To the right.
Okay, think about this one then. How would you graph and write in interval notation this example? Suppose I wrote x is less than or equal to negative 3. Give you a couple of minutes while I'm going to read attendance, but the ones that I already have on my attendance list, I'm going to say, and I have you here. I'm just going to read your name, but I'm going to, I'm also going to say if I noticed you were here. Azia, Aka, and I saw you were here.
Yes, I'm here.
Nashia, now I saw you came up with a different name,
I am here.
but you're here. Your first name is different enough. It's not like just James, so that I could see that there was nobody else with that same first name. Annabelkis, I see that you're here. Emma,
Yes, I'm here. Yes.
Okay. And Emma, I see you're here. And I have to tell you, Emma is going to keep our class going because she keeps asking questions and making comments. And I'd love all of you to do that, because I really see that that helps all of us. Messiah, I have you here. April, I have you here. Khadija, are you here? Khadija? Yeah, I see you're here. Okay.
Yes, I'm here.
I love your pink mask.
Thank you.
Thank you for coming on in person. Makes a very big difference. Yakima Ellison. Is Yakima here?
I'm here.
Okay, I have you marked absent for Tuesday. Were you absent or were you here?
I was absent Tuesday.
Okay, good. Okay, Cheryl, I have you here. Sebastian Gray. Is Sebastian Gray still in this class? Does anybody know?
Oh, it's not here. It was here the first day.
Okay, I think he might have not be in this class anymore. Stacy,
Miss Pearl, did you say Messiah?
I did. I said.
I'm here. I'm sorry, I didn't hear you.
And not only that, but I have you marked here because I saw you on the, I said Messiah and I see you that you're here.
Oh,
Okay.
yeah, I didn't hear you. I'm sorry.
That's fine. That's why, because I didn't say it very loud because I just skipped over. I saw you were here.
Okay.
Stacy, I have you here.
Yes, I'm here.
Natalie, I have you here. Erica Mark. Is Erica here? Okay, I don't have Erica here. Okay, Jonathan, I have you here. Luke, Mena. Is Luke here?
Here.
Okay, good. Layla, I have you here. Ashley, I have you here. Kachira, I have you here. Jennifer, you came on now. I have you here. Rachel Seeley, I have you here. Gloria,
I'm here.
okay, great. And Corey, is this your first time that you're here, Corey?
Yes, I had scheduling issues until recently, and they had dropped 2 of my classes, and they recently just put 2 of them back on. So,
Okay.
like,
I have
technically my first
you
week.
are on my roster. So are you okay with what we've been doing today?
Yes.
Okay, great. All right, so let's now.
Yeah, Professor.
Yes, question?
Yeah, you didn't call my name, but I'm in here.
Well, you're gonna have to tell me who you are.
Umar.
You didn't call my name. It's Denisha.
I have Umar, I have Umar here, so I probably just, I'm sorry, and who else didn't I call? Oh,
Denisha.
Denisha, I have you here.
Okay.
Denisha Harris, right?
Yes.
And I did mark you here, and I just, I saw you. Okay, so I really sort of concentrated on the people that I didn't see. Okay, and I see people are putting in the answers. Let's see how this looks on the number line, and let's see how it looks on the in interval notation. Okay, we want x less than or equal to -3. So here's my -3. Do I make a filled in or an open circle at -3?
Filled in.
Filled in.
Open circle.
How many people think it should be open? How many people feel that it should be filled in?
And
I think it
Me.
should be filled in.
I think it should be filled in. Also. How do I
It
know
should be closed.
It should be filtered.
it should be filled in because there's this extra little. I know it doesn't really look like an equal sign. It looks like one of the part of, because part of the equal sign is the inequality. But this is the equal sign. Whenever there's that extra little line over here, it means we've got to fill in the circle. Okay, I'm getting some. I'm gonna mute everybody because I'm getting a lot of extra noise. Again, you can always unmute yourself at any point. Just unmute yourself. I just do it when I think that when we're I'm talking, it's easier if you're muted. Okay, now we have to decide which way do we run our arrow. Well, here's my arrowhead. It's pointing to the left. So this is going to be how it looks. Did everybody look at that on the number line and say that's how it looks?
Yeah.
Okay, now,
Yeah.
Yeah.
Yes.
so well, now let's talk about interval notation. Okay. I know I'm going to have two numbers. What number do I put first?
Negative infinity.
Negative infinity. How
It's
do I know?
farthest left on the timeline.
Because all the way to the left, oh, you can't even see, all the way to the left is where negative infinity is. And even though the arrow looks like it's starting here and ending here, for interval notation purposes, you always have to start on the left and work your way to the right. So all the way to the left is negative infinity. And with an infinity sign, we know we always put a parenthesis. The end of the interval, the last point, the point that's all the way to the right is the -3. And do we enclose this -3 with a parenthesis or a bracket?
Bracket.
How do we know it's a bracket?
We know it's a bracket
Because the
because
circle is
Because it
filled.
ends at 3 and -3.
Yeah.
no, because you use the brackets when
Because it's greater than or equal.
yeah, because it's the filled in circle.
Right. When we have less the either greater than or less than or equal to, that in additional little line there that makes it equal to, which makes the circle filled in, that's when we have the bracket. And everybody was saying the same thing in different terms. So this would be the correct interval notation for this. Now that we've done a few of these, I don't remember who asked me the question at the beginning and didn't know whether we use a filled in or not filled in, a bracket or a parentheses.
That was me.
Has that been cleared up?
Yes.
Okay. So now we want to go to the next step. What is the next step? The next step is to take something a little bit more complicated than this inequality and solve it and put its answer on the number line and also in interval notation. As you see, there are 3 different ways that the answer could be given. Now, sometimes when I'll give you a test, I'll ask you just to do it one way or just to do it the other way. And you'll see when there'll be homework on Delta Math that's going to be due. It's not due tomorrow because I think that's a little quick, but it will be due on Tuesday. Again, if you didn't do the original homework, you can always I give a late date for every homework until the end of the term that gives you 90% of the credit. If you do the homework on time, you get 100% of the credit. If you did it late, don't think, oh, I missed the homework, so forget about it. Don't go back and do it because you get 90% of the credit just as long as it's done. And at the end of the term, I'm going to use that homework as part of your mark. So you want to make sure you do that homework on Delta Math. Corey, did you see, I don't know if have you been able to sign on to Delta Math, or do you have are you able to get onto your Blackboard?
Yes, I actually went and looked at it when I found out all of my courses had been added. I looked through them to see what was there, and I saw that you had a homework, and I went and did it.
Okay,
So it should have been done, I think, like the day after.
Because you're here a couple of days late, please just email me and I'll respond and help you out with it because
It's done.
again, okay, but I think it's sort of self-explanatory. Okay, so let's look at a more advanced type of inequality. I'll start with something that's really pretty easy, and then I'll go on to something that's a bit harder. Suppose this is from that, I know I called it homework, but it's really classwork. that sheet that I send you. And I will be sending you more, I'll call them study sheets that are sent out by the department. So because those are the type of questions you're going to see really on midterm or final. So I'll be starting to do that for each chapter that we cover. I will send you out what I call a study sheet, which is mostly we'll do it in class. Again, the homework is basically on Delta Math, but I will give you other sheets. There's study sheets, and I'll give you answer keys with them so you can prepare yourself. And we're constantly, from day one, preparing for those two big tests, the midterm, which is worth 25% of your mark, and the final, which is worth 35% of your mark. So those two departmental exams together consist of 60% of your mark. So we want to make sure that you are well prepared for those. Okay, so let's say I give you a problem that looks like this. I have 5x plus 10 is less than 20.
Whoa.
Okay. Obviously, this is a lot more than just an x greater than something or an x less than something.
Yeah.
But if you think about it, you really know how to do this, because solving an inequality is really the same exact steps that you use to solve an equation. Think about this as if it's an equal sign.
Okay. So
if you said 5x plus 10 equals 20, that wouldn't phase you. You'd know how to do that. So we do this basically exactly the same way. There's going to be one change, and I'm going to talk about when we get to that change, when it's necessary to get to it. Just like in an equation, the first thing you want to do is combine like, remove parentheses, we'll learn them. Combine like terms, well, on this side all the terms are combined, on this side all these terms are combined. So we've done step 1 and 2 of our regular, we didn't have to do anything, it was already done for us. So now the question is, we want to get all the letters on one side and all the numbers on the other side. And specifically when I'm doing this, I want to make sure that I'm left with the x on the left side. I do that with equations as well, but it's not so necessary. In other words, if you get an answer that says 7 equals x, it's the same, means the same thing as x equals 7, and you could just write 7 and it doesn't matter. But when it comes to an inequality, you want to write the inequality with the x on the left side, which means I want to get this 10 to the other side. So I'm going to subtract 10 from both sides, just like I would on a regular equation. This will leave me 5x. This cancels out.
mhm.
I just bring down the inequality sign. It's still a less than sign. And I do 20 minus 10, which is 10. So step number 1, add or subtract so that everything is on one side. Step number 2 is now we have only x's on the left side, only numbers on the right side. We now do exactly what we did with an equation. We divide by the coefficient of the x.
Mhm.
Coefficient of the x in this case is 5. So I'm going to divide both sides by 5. Now here's where, listen carefully, here's where there might be a change. If the number you are dividing by is a negative number, then when you divide it, you have to change what we call the sense of the inequality. We have to change the direction of the inequality sign. The only time we ever change that direction is if we're either multiplying or dividing both sides by a negative number. If I'm dividing by a positive number, I leave it alone. If I divide by a negative number, I switch it. That's the only place inequalities are different than equations. And the reason is because This is something that never really came up in an equation, because there's only one symbol for an equation, an equal sign. But with inequalities, there are 4 symbols, so we have to be careful. We basically keep the symbol the same unless we're dividing by a negative number, unless we are dividing by a negative number.
So this one stays the same.
Okay, are we dividing by a negative number?
No, you're not. So it's, I say,
So on this side, we're getting X. On this side, we're getting 2.
Mhm.
And we didn't divide by a negative number, so we leave the inequality the way it was. So my final answer is X less than 2. Do you notice that this is no harder than doing an equation? You have one extra important fact to remember, but everything is the same. Of course, now we can put it on a number line like we did before, because now it's a simple X greater than or less than, and we can put it in interval notation. Here's my number line. It's an open circle because it's just a plain less than sign. It's an arrow going to the left because this arrow is pointing to the left. Here's my number line. And in my interval is starting here at the left at negative infinity. And it's ending here at 2. And since this is an open circle, because this was just a plane, it didn't include the 2, we use a parentheses. So this is here's the answer is an inequality. Here's the answer on a number line. Here's the answer in interval notation. Okay, I'm going to do one more, and then I'm going to give you one. Then I think we can break up into groups, and I'm going to give you time to do, I'll say 3 problems. Okay, and I will write the 3 problems on the board before I break you up into groups in case you don't have these sheets here with you. I'll probably take it right off the sheet.
Professor, I know you said that number 3 is interval notation. Number 2 is the number 9, and number 1 is what?
Just the inequality.
Okay, thank you.
Just like a regular answer. Usually they'll ask you to give your answer in interval notation. This is probably the most common way that you're asked to give an answer though. But all 3 of these, there are correct ways of giving the answer as an inequality, on the number line, and in interval notation. So here's another problem for you. This actually is problem number 17 on that sheet that I had given you. It's 2 parentheses 3 minus 2x close parentheses plus 5x is less than or equal to negative open parentheses negative 2x minus 3 close parentheses.
Whoa, bro.
Okay, want to try it on your own before we go on to do it together?
No.
Yes.
Wait, where's
Yes.
where are the brave people here who want to try something on their own? Okay, I'm going to give you a couple minutes to try it on your own. Restarting the recording. And let's look at this problem. And let's pretend this is an equal sign for the beginning. Just like with an equal sign, the first thing we want to do is remove the parentheses. So in front of the first parentheses, I see the number 2. So I'm going to multiply. I'm going to distribute the 2 and get 2 times 3, which is 6, and 2 times negative 2x minus 4x. And I'm just going to bring down that plus 5x. And I'm just going to bring down that inequality sign because I haven't done anything that would make me change that inequality sign. And on my second side of my equation, And I also see a parentheses. But in front of the parentheses, and I think this was your question, in front of your parentheses, there's just a negative sign without a number. So if you recall what I said, it's as if there's just a sign and not a number, it's as if there's a 1 there. I'm putting the 1 in red. I don't know if you can see that it's red, to indicate that it's like when we have just x. X means 1x. A parentheses without a number in front of it means there's just one of them. And we're going to distribute -1. So -1 times -2x is positive 2x. And -1 times -3 is positive 3. Now, you could have said, oh, a negative in front of it. I just changed the signs and you would have been correct in that assumption as well. Notice it gets you to the same place. But I like to think of it as multiplying by a -1. Okay, now on my left side, I see there's two terms that can be combined. There's a -4x and a positive 5x. So I'm just going to bring the 6 down. -4 plus 5 is 1. So that's a positive 1x, which I can either write as positive 1x or just positive x. And on the other side, there's nothing to combine, so I'm just going to bring it down. Now, remember my intention. In inequalities, I'm going to bring the x's to the left, the numbers to the right. So this 6, which is a plain number, I want that to end up on the right, so I'm going to subtract. And it doesn't matter what order you're doing this in. If you do take care of the x's first or the numbers first, it really doesn't make a difference. So this gets canceled out, and I'm left with just...
Wait, Professor, you lost me.
Okay.
Can you repeat that again, please?
Are you okay up here?
Yeah, right there. Can you repeat it there?
Yeah, please.
So everybody's okay with 6 plus x is less than or equal to 2x plus 3. You're okay with that?
Wait, how you combine? Wait,
Okay.
the 6 stays the same?
These two numbers are like terms, correct?
Yeah.
But 6 is not, so I just bring the 6 down.
Okay.
And I have to add a -4 plus a 5. How much is -4 plus 5?
Just X.
Just x.
Mm-hmm.
That became 6 plus x, and this just stayed the same, right?
Okay, yeah.
Now I want to get the numbers to the right side, which means I have to get rid of this positive 6. There's no sign in front of it, which means it's positive. So that means I have to minus 6, correct?
Yep.
But if I do -6 on that side, I better do now. I'm going from one side to the other. I'm crossing the barrier, so to speak. So I have to do -6 on this side.
I don't know how to answer
So
this.
this just leaves me with an x.
Let's
I
start.
keep the same sign. Remember, I'm only changing that if I ever divide by a negative number. So otherwise I leave it alone. The 2x I leave alone. And I combine positive 3 minus 6. How much is 3 minus 6?
-3.
It's getting better because now I don't have so many things going on, but I still have x's on both sides of the equation, of the inequality. So I have to get the x, all the x's to the right.
Take a look at this question.
I mean to the left. I want all the x's on the left side, which means this 2x on the right side I want to get rid of. It's a positive 2x, so to get rid of it, I'm going to do minus 2x.
On a
And
different
minus 2x on the other side.
tapping the done button to move on. There are 5 bananas.
Okay.
Look. Tap on the number 5.
I hear somebody, I don't know, is that bothering anybody, the noise in the back? Okay. So now we have on this side a positive x and a negative 2x. So this is a positive 1 and a negative 2 is a negative 1x or a negative x. And over here, this is a 2x minus a 2x. That got canceled out. And this is -3. So I have negative x on the left, less than or equal to -3 on the right. It's almost finished, but I'm not interested in what negative x is. I'm interested in what x is. So what am I going to do with this? This is like a -1. I have to divide -1 on both sides. And when we divide by a negative number, here's where we have to be careful. That's the case where we switch the direction of the inequality. So this will give me negative x divided by -1 is x. The less than or equal sign becomes a greater than or equal sign because we divided by a negative number. -3 divided by -1 is +3.
Let's go.
How many people got an answer x greater than or equal to 3? Yes, this is about as complicated as they can get. But if you could do an equation, you could do the inequality. Okay. If we want it on the number line, I'm going to go on top. Here's the answer on the number line. Here's 3, 1, 2, 3. At 3, do I make an open circle or a closed circle? Closed, because this is greater than or equal to 3. It has that extra equal sign. And the inequality says greater, which means it looks like it's going to the right. Here's my arrow going to the right. That's my answer. So here's my answer as an inequality. Here's my answer on the number line. And if we want the answer in interval notation, I'm running out of space, so I'm going to do it right over here. Here's my interval notation. My start, remember, is always on the left. The first number on the left is the 3, and it's going all the way to positive infinity. And do we make a bracket or a parentheses? Bracket, because it was a filled-in circle. But at the parentheses, we make but at the infinity, we make a parenthesis. Any questions about this?
I have a question.
What?
So
You feel like answer it.
so going back to where we divided the negative, we got the negative x over there.
Right here?
We don't want negative variable.
If I gave you an equation, would you leave your equation, your answer, -x equals -3? Would that make you, would it mean your answer is -3? Whenever you're looking for an answer, your answer has to be starting with just a plain x. If there's a negative, it's just the same thing that we said before. It's as if this means -1x. It's not a plain x, it's a negative -1x. This x is being multiplied by -1. To get my final answer, I have to divide by the coefficient of x, which in this case is -1. So I can't leave it at -x. That's not a complete answer. I have to get it to plain x. Was that your question?
Yes. Okay.
Does that answer it also?
Okay. And then one follow-up. So why does the symbol get flipped after that?
Because whenever we divide by a negative number, or if usually we don't multiply by numbers, but if we should multiply, or more important, divide an inequality by a negative number, it's the only time you have to switch the inequality. Now, do you want me to prove why that is, or are you willing to accept that as a rule?
Could you prove why that is?
But sure, if you.
Do you want me to show you why?
Yes.
Okay.
Yes,
Yeah.
please.
I'll give you why, but this is enrichment, okay? Everybody can listen. Look at this number line. Let's say I have here's a 1 and here's a 2. Okay? it's clear that 2 is to the right of 1. So therefore, 2, we know, is greater than 1, correct? Would you say that's a correct statement?
Yes.
Okay. I'm going to divide both sides of this inequality by -1. I'm dividing them both by the same negative number. Emma, I wouldn't even bother writing this down. I see you're trying to write it, but it's just
I'm trying to
listen.
solve the next problem, honestly. But yeah.
Oh, okay, okay. How much is 2 divided by -1? Corey, you were over here, so you're on the, how much is 2 divided by -1?
Oh, sorry.
What, how much?
Um,
Don't I get 2 divided by -1? -2.
-2.
And how much is 1 divided by -1?
-1 or 0.
-1. Okay. Here's my -1. Here's my -2. Which number is bigger? Is the -2 bigger or is the -1 bigger?
-2.
negative
-2. Remember,
-1.
right, because if the number, which one is to the right? On the number line, if the number is to the right, then it's the bigger one, and the one on the left is the smaller one. So obviously, -2 has to be the smaller number.
Yeah, isn't it when the number's closer to 0 is the biggest?
Right. So this means that, look at what happened. I started out with 2 greater than 1, which was obviously true. I divided both sides by -1. And what happened is that the greater than symbol had to be switched to a plus. When you divide by a negative, I took a very simple negative number to divide by, but when you divide by a negative, that's what happens. It inverts the inequality. And it's just a rule that you're really going to have to remember. It's the only rule that's basically different than regular equations. Okay. Now I see I took up more time than I expected to. So here's what I'm going to do. Instead of breaking you up in breakout rooms now, because it doesn't make sense anymore, I'm just going to leave you, aside from the homework that's on Delta Math, I'm leaving you these problems to do. And at the beginning of class tomorrow, these are the only thing that are going to be due for tomorrow. The other Delta Math is due for Tuesday. But this is due for tomorrow. I'm going to ask different people who are willing to offer themselves to volunteer to present each one of these problems. Now, when you're going to present a problem to the group, you have to have a way, either you're going to have to tell me what to do, if you have a way of doing it, if you do it on you can take a picture of it and I can allow you to share my screen. But I'm not telling anybody who's, but be prepared. See if you can volunteer to do one of these 3 problems. You be the teacher. I need a little bit of a break. So I need somebody else to be the teacher. This is as hard of an example that you can get when it comes to inequalities. The only thing that might be different would be if we have fractions. And if you recall, I said I'm going to leave the fractions part for later. When we're going to do our next problems all without fractions, or if we use a fraction, we're going to use a very simple fraction. And when we come to our fraction chapter, then we will really examine fractions totally. Does anybody have any questions or anything they want to comment? Or I hope, did everybody find that this worked okay for them?
Yeah.
Okay. If you want to know where these problems went, I actually took these problems off of the sheet that I had called the homework sheet for that's on the first, on that first lesson. I'll probably be putting more sheets on, but this was actually number, if you want to see it on that sheet, this was number 4 on that sheet. This was number 15 on that sheet. And this was number 16 on that sheet. So if you want to look at it, if you see it on this sheet, remember this is a sheet that it really asked you to print out. I called it homework, but it's not homework. It's just, except these 3 problems are homework for tomorrow. Is everybody clear as to what we should be doing at this point?
Yes. Yeah.
Okay, so have a good rest of the day.
You too.
And stay healthy and safe, and be careful on the ice out there because it was pretty icy where I am. And I'll see you tomorrow at 10. Is there anybody who would want to speak to me now, or can I end the session for everybody? I mean, everybody can leave, but if is there somebody who wants to specifically speak?
Thank you. Have a great day.
Thank
Okay.
you.
Bye.
Okay, bye. Anybody wants to speak to me?
I mean, I just wanted to clarify that.
Yes.
I did do that homework that you
Okay.
posted on Delta Math already.
Who's that, Corey? Who was talking to me?
It's Corey. Mhm.
Yeah. Okay. Here, let me.
I did it already I did it on the 3rd.
Oh my God.
How come?
Okay. I'm gonna, first of all, let me just stop the, I think we don't need to record this anymore.